Friends, today we are going to discuss a very important topic of chemical kinetics, that is zero order reaction. So, zero order reaction. Zero order reaction. So, how this reaction proceeds and how to write rate law equation, let us see. Let's suppose our reactant A forming product B. Then we have rate law dA minus of dA, since here we are taking the concentration of product, so minus dA by dt is equal to K and is proportional to A to the power 0, since it is zero order equation. So this implies dA by dt is equal to minus of K. Here let's suppose the initial concentration of A is A0 and it changes to final concentration of A. In initial concentration of A at T is equal to 0 and final concentration of A at T is equal to T. Now on solving, we have dA is equal to minus K dt. This implies on integrating we have both sides, we have taking limit A0 to A. So here limit A0 to A is equal to minus K, and here limit is 0 to T. So here limit 0 to T. This implies A minus A0 equal to minus of KT, or A is equal to A0 minus of KT. A is equal to A0 minus of KT is the integrated rate law equation for zero order reaction. Now here A0 is the initial concentration of reactant. A is the final concentration of reactant. K is the rate constant and its unit of rate constant, as we know, unit of rate constant is equal to mole per liter. Let's see it on next page. Mole per liter to the power 1 minus n per second. Here this n is order of reaction, order. So mole per liter to the power 1 minus 0 per second. So mole per liter per second is the unit of rate constant for zero order reaction. Now trick, or first let's discuss the half-life of zero order reaction. So we have equation, integrated rate law equation, A is equal to A0 minus of KT. So for half-life, this A is equal to A0 by 2. So A0 by 2 is equal to A0 minus of KT. This implies this is half-life. Now this means A0 by 2 is equal to KT half-life. So T half-life is equal to A0 by 2k. A naught by 2k. This is the half-life for zero order reaction. Now let's suppose we have, if this is the reaction, then T half-life is this. Now if this is the reaction, then what will be the T half-life? So T half-life in this case will equal to A naught is the initial concentration, A naught by 2 into 2k. This 2 multiplies here. Now if this is the reaction, now then T half-life is equal to A naught is the initial concentration of A. Now 3 into 2k. This 3 comes here. No meaning of this 2. So this is half-life. Now we have average lifetime, average life of zero order reaction. So what is average life? Let's suppose we have A is equal to A naught minus KT. So average life is denoted by tau, and it is the time required for all the reactant composition converted into product. So it takes tau is equal to, we have tau is equal to A naught by K. It is the total lifetime for completion of zero order reaction. Now let's discuss trick how to attempt the problems of zero order reaction. So if we start with, let's draw a line. Here we have half-life means T 50% completed. Here 0% means no reaction, no product form. Here 100% means all the reactant converted into product. So here T half-life is equal to A naught by 2k, and here we have time tau is equal to A naught by k, time for completion of zero order reaction. Now if we want to calculate time for T 25%, so what will be the time for T 25%? So T 25% time will be the average of this and this time. So average on adding A naught by 2k along with 0 by 2. So we have T 25% is equal to A naught by 2 into 2k, means A naught by 4k. Now in the similar way, if we want to calculate time for T 75% completion, so time will be average of this time and this time, and this will be A naught by 2k plus A naught by k divided by 2. So this will be, if we take A naught by k common, then 3 by 2 by 2 means this will multiply by 2 here. So this will be A naught 3 A naught by 4k. So this is the time required, 3 A naught by 4k. This is the time required for T 75% completion. Now let's take example to understand this. Suppose we have a reaction and its T half-life is 16 minutes. So here we have T is equal to 0, since here reaction not starts. So here T half-life. Now let's tell me what is the time for completion of reaction. So here we know that it is half-life, so completion of reaction required 2 times. So 32 minutes required for completion of reaction. Now let's tell me what is the, it is T 100%. Now for T 25%, what is T 25%? So T 25% is equal to calculated by average of this two. T is equal to 0 and T is equal to 16 minutes. 0 plus 16, so 0 plus 16 by 2 is equal to 8 minutes. So if in this way, if we want to calculate T 12.5%, means half of 25, T 12.5%, so this will be here, this will be, it is 8 minutes plus 0 by 2 means this is 4 minutes. In the similar way, we will calculate each and every time for the zero order reaction. So this is the direct process. In this way, we will see all about the zero order reaction. Now let's see some graph. So first graph is reactant versus time graph. Reactant versus time graph. Now we know that A is equal to A naught minus KT. This is the integrated rate law equation. Now this equation is of type y is equal to C minus mx, or this will be minus of mx. Here slope is negative. So slope is negative, and this is the equation of a line, straight line. So slope is negative means this reaction proceeds, this graph proceeds as, here slope is negative, and we see that here we have intercept is equal to A naught, here we have A concentration, and here we have time, it is the concentration of reactant. So here it is intercept A naught. Now here we see that A concentration of A becomes 0. Here we see the concentration of A becomes 0. Now when the concentration of A becomes 0, only at the time of completion of reaction, that is tau at T is equal to tau, that is average lifetime, and it is equal to A naught by K. So in this way, this point is A naught by K. This point is A naught by K, here A naught by K. Now we have another graph for product versus time. For product versus time. So let's draw the product versus time graph. Product versus time graph. So we know that we have equation A is equal to A naught minus let's write it like this, A is equal to A naught minus KT. Now if reaction proceeds from A to B, and here we have the concentration of A initially A naught, and here product 0, so A naught minus X, this is A and it forms X, so this A comes here. Now A naught minus X is equal to A naught minus KT. So this A naught cancels this, and this negative sign cancels this. So X is equal to KT. And what is this X? This X is concentration of product at time T is equal to T. At time T is equal to 0, at time T is equal to T, the concentration of product is X. So concentration of product, this is concentration of product and this is time. So product versus time graph concentration of product, there is time graph drawn like this. So here x is equal to kt, since y is equal to mx type graph. Here m slope is k, the rate constant, and intercept is equal to 0, so no intercept. Plus c, here c is equal to 0, no intercept, so graph like this, drawn like this. So graph is drawn like this, and here we have slope is equal to m. Slope is equal to m is equal to k. Here k is the rate constant. This m denotes slope. So k denotes the rate constant. So here slope is k. This is time, and this is x, concentration of product, axis. In this way, the product versus time graph is also drawn. So thank you very much. And one thing more, please like, share and subscribe. Thank you very much. Also comment, subscribe and comment also, so that I will make videos according to your choice. Thank you very much.